MacBride is a polymetallic exploration project with proven prospectivity for copper, zinc, gold, and silver. So basically, critical metals and precious metals. It has 2 drill-defined deposits, and we saw MacBride as potentially value-adding resource for our Lynn Lake project, which is 65 kilometres away. At Lynn Lake, we have excellent infrastructure, including hydropower, large resources of nickel, copper, cobalt, sulphide, and really MacBride had high value, high grade mineralisation that we thought would be beneficial for the project. Since we've started the project, we've kind of changed our mind on that. We now believe that MacBride is a standalone project in its own right, or has potential to be a standalone project in its own right. And we believe it'll be off the foundation of multiple polymetallic massive sulphide deposits. MacBride is an old exploration project. As I said before, exploration commenced in the late 1940s, early 1950s. The most recent on-ground exploration would have been the early 1990s. So much, just about all the exploration information, all the exploration data we have is in paper format, off and based on non-real world grids. So basically lines cut in the bush. So we've taken steps to collate all this data, get it into real world coordinates, and it takes time. There's a lot of valuable information there, and there's a lot of copper, gold, and zinc identified on surface that we need to pull into real world coordinates. To our benefit, in 2008, an old Australian company, Western Areas Limited, now no longer going, but a very successful exploration company, they flew a geophysical survey over the MacBride deposit and the immediate surrounds. And we've never seen where they processed this data. We've acquired the raw data, processed it, and lo and behold, along strike from the MacBride massive sulphide deposits are multiple conductors. And in fact, the MacBride deposit itself is also represented as a conductor. So with this in mind, we've taken that historical exploration, the geophysics, the method for the geophysics used by Western Areas, and we've applied that to the whole project. Before Christmas, we announced that we've embarked on a geophysical survey that will cover the full 14-kilometre strike of our project, including a whole heap of projects, tenement areas that we picked up just before Christmas. Yeah, this information has been critical for us. For a start, it's allowed us to be certain that the geophysical methods we're implementing now work. As I said before, the geophysical method we're using has identified the MacBride deposit. 1-to-1, we can see the geophysical conductor with the drilling, so that's good. And from that early survey, which covered about 4 or 5 kilometres, we've extended that to the full 14 kilometres. So we expect to identify multiple deposits, including the area around the Wellmet deposit, which has never been geophysically tested, and a whole heap of other base metal shows that we see on surface from the historical mapping. So that's critical. We're on the front foot there. The other thing is quite interesting is the variety of mineralization we see. And this style of mineralization, the world-class centers are polymetallic. You do see copper dominant deposits, you do see zinc dominant deposits, gold and silver, and we see all those within this project area. The MacBride deposit itself is zinc dominant with a bit of copper. The Wellmet deposit has that, but it's also got a copper gold dominant zone as well. So it's very encouraging for us, and there are examples of world-class systems like this in the Manitoba province where we're exploring just 250 kilometres to the south. There's the Flin Flon Snow Lake area where these style of deposits have been mined for more than 100 years. So it's quite exciting for us. Yeah, as I said before, the geophysics is critical. It allows us to really hit the ground running and identify the targets for drilling and going forward. That's almost finished. We hope in the next couple of weeks we'll be able to announce the end of that geophysical survey, the early result, and then we go through a process of interrogating that data, critically defining the drill targets and prioritising those, along with the quality drill targets we announced just before Christmas. So marrying all that together. I mean, if you had to look at the historical work, the MacBride deposit would not be the priority drill target, even though it's what's been drilled in the past, and that's because it exists at surface, so they knew what they were drilling. If you had to pick from the geophysical anomalies we have to date, MacBride would be the 4th or 5th ranked target. So there's already some pretty good targets for drill testing. Subsequent to that, once we've got our drill program set, we go and get the approval process done, and then we basically hit the ground running. Timing wise, it's a bit uncertain at the moment, but the perfect time would be the end of winter and the start of spring. The snow starts to melt. We can drill now. There's not a problem. Drilling in winter is fine, but you see a lot more in the ground as soon as the snow disappears. So you're probably looking at what we discussed before, late February, early March at the earliest.